Hey there, peopleage. Your friendly neighbourhood Jodocast. It has been a long time no hear from me. You know what I mean. Anyway, I have managed to get my hands on a Nerf Rival Khaos. Saw these and I wanted one desperately, so I managed to find someone selling one here in Australia for a reasonable-ish price, so I jumped on it, and here it is. So I have got some plans for this. I have been putting together some bits and pieces and what have you, some design ideas of what I'd like to do. Cosmetically, I'm going to keep the blaster primarily very similar to the way it is, just a few minor cosmetic changes, in that I sort of want to paint this front section of the barrel apart from the very tip black in here, same on the other side. Going to have a few little switches and what have you in different spots for different purposes, because what I'm planning to do on this one, or to integrate into this one, is in taking Tom from Foam Data Services advice and sort of looking into everything that he's been talking about, the MOSFET technology, and using that, it makes a heck of a lot of good sense to me to keep your standard switches in the location for your electronic blasters. They fit in there perfectly. They're designed for it, so if you can use them, use them. Now, by using MOSFET, you're not sacrificing being able to use your higher amperages and voltages, because essentially it acts like a relay type system. So you're just using your factory switches as triggers, pardon the pun, to then flick a relay, which is then drawing your power directly from your battery source through the relay straight to your motors, or same with the pusher motor. So what I have done is I made up this little prototype board, which is a little two-stage board, which basically has a single input and two outputs. So what it will do is it has a rev trigger input and then a pusher input. So the rev trigger input feeds the pusher input, so you can't run the pusher unless the flywheels are revved up. So so that's kind of how I've designed it to work. So your first stage will rev up your flywheels. The second stage will activate the pusher, providing the flywheels are active. So that's a little board that I sort of designed and built as a prototype, which I've tested and it works quite well. The other thing I'm going to do is I'm going to integrate a laser sight, like a little red dot laser sight, which will be integrated up the front. Also a torch will be integrated, which will also have a solid and a strobe effect, so you can actually use it as like a tactical strobe type effect for distracting the enemy, etc. I'm also going to use a pulse width modulator on the pusher motor so that it will have a variable rate of fire. Also going to incorporate a battery meter so that at any given time you can push a button and see exactly where the voltage, well, not the voltage, this actually gives you a percentage full, so it will tell you how full your battery is. And I'm going to put a low voltage warning buzzer in there as well, so when your battery's getting low and needs to be swapped out, you will have the buzzer to alert you to that fact. The beauty of this system, of the way it's all going to work and what have you, and used in the MOSFETs, is that it will work on an 11.1 or a 14.4. So a 3-cell or a 4-cell lipo. It'll work perfectly on either. And in fact, if you wanted to drop the voltage back and run a 2S or something like that, it will still work. Or even if you wanted to put the factory battery tray back into it, it will still operate. It'll still work. So that's kind of the idea. Now it's just a matter of putting it all together and installing it all. So that'll be the next step. So we'll leave here and then we'll come back and I'll start to dismantle the blaster and we'll see what the internals look like and what we can fit in where. Now, unlike what other people have done where they replace the switches, we're not doing that because we're using the MOSFET board, which, after sort of looking into it and watching a few of Tom from Foam Data Services videos, etc., I have to agree, it looks like a far superior way of actually setting these things up, because you can keep everything exactly the way it was designed, using the switches that were designed for the spot and what have you, without having to worry about putting high amperage, high voltage amperage through them. So okay, so that's all that crap out the way. This motor, look at that, too easy. Okay, these little bastards hold me captive, so we'll snip these off. Glue shit off here. Let's get our soldering iron, heat it up, we'll desolder this crap.
MOSFET. Fit in there just fine, or we could put it up here. The additional componentry like the pulse width modulator. So really I'm probably going to put that in here. This is like really weird from you, but you know, whatever works, right? It's close, but not so hard. It's got to go down a bit lower. This junction here ain't fitting. It's got to come down. So there you go, so you can see the effect. He's got to take that out. Yeah, so it's taken a fair chunk out, but it's allowed me to be able to drop that in. Once we get that should sit in. Stiga should get strobing light, which you are. See? Strobing light. Okay. Which is going to be a centre off, and then one side will be, so it'll be centre off, one side will be for your constant torch, and then pulling it back towards you will give you your strobe effect. Centre off. Alright. position you get a constant torch. In the forward position you get a strobe. Off, torch, strobe. So there you go. Get them nice and parallel, and if they're really tiny, put a little elbow in them. Not too tight, but tight enough. You get your length of wire, pull it out reasonably taut, hold it at that end, and then you get a nice set of twisted wires that you can use to run together but not be a pain in the buttocks. test there, you can see percentage battery. And you push your little button, comes up, gives you the battery meter 100%. Okay. Up your uncle, you got your battery meter on top, your adjustable cyclic rate, your torch, integrate it into the end. Alright, slide it up and put a couple of test shots through it. Yeah, it shoots. Alright, so here it is finished, my Nerf Rival Khaos Mod. Almost finished, the paint's still drying, but apart from that, it's pretty well done. Okay, take you over the features. Obviously had a lipo replacement, rewire, etc. You got the little battery meter on top there with the push button on the side. Comes up, gives you your battery reading, 97%. The front end, you've got integrated torch, which you've got, pull it back towards the pistol and it's just a standard torch. Push it forward towards the barrel and you've got your tactical strobe.
centre off. On this side also the barrel's been painted in black, and you've got your pot for your cyclic rate adjustment, so you can actually turn up or down your rate of fire. That's pretty much it. Now all that's left to do is a firing test. So I'll set the camera up and we'll do a firing test, etc. Okay, so we're going to do a bit of a firing test. I've been an idiot mucking around and doing stupid things. I made a target. This is a test run, so hopefully it works alright. The idea is that it will actually collect the rifle rounds and actually reload a magazine for me. So, because I've purchased a second magazine, so the idea is that get the magazine, put it in the little receptacle on the side here, slides up into there, loads in, then you lift up the little top jam door, and that little piece just that piece up, and also gives you a little sort of rebound for the balls for when they come out. Alright, so that's a little targety type jigger, and that's we'll set that up just here, like so. Okay, so there's that target, so I'll set the camera up in front of it, angled backwards. And magazine. So yeah, you have to adjust a few rounds here and there. And essentially 87%. Okay. Now we've got the adjustable cyclic rate, so we'll try and adjust that down. So yeah, you can see you can drop it right down to like 1 a second, and then all the way up to whatever that was.